Friends, this video is an introduction to what is known as rotational dynamics. It's an important topic in physics, especially if you are preparing for your HSC examination, 12th standard examination, board examination, and then this video might be useful to you. Rotational dynamics, as the name indicates, is about rotation. We know that circular motion is an essential part of our daily life, and in your real life you'll find many rotating objects as well as revolving objects. So you know that rotation is motion about the axis passing through the object. That if you take a ball and if you just move around, that is a rotation. But if you take a ball and maybe you throw it around a certain body, or for example the planets which are moving around the sun, that is a case of revolution. So revolution is different and rotation is different. This all of us understand. So during revolution the object undergoes circular motion about some point outside the object, whereas during rotation the motion is about an axis passing through the object. The key concepts which you might recall in our earlier classes, they are circular motion, wherein the motion is along a circular path, but the velocity changes since the direction changes, and the speed might also change. Another important concept was the center of mass, wherein we know that we assume that the entire mass of an object is concentrated at a fictitious point, and that point is called as center of mass. We also have come across a term called as kinematical equations, where these are basically the mathematical relationships or mathematical formulas which describe the motion with constant acceleration. And then we have been introduced to what are known as real forces, that is actual forces, and the pseudo forces, especially in the non-inertial frames. Circular motions, we have studied that basically it is an accelerated motion, because what changes is the velocity there. As direction changes, it might change even the speed, but there could be cases where the speed is constant and the direction changes. So circular motion is essentially an accelerated motion, and it is periodic. Periodic in the sense that the particle repeats its path along the same trajectory, making it periodic in space. So these are the characteristics of circular motion. The kinematics of circular motion, that is, if you want to describe the circular motion, then we need to use some terms which are analogous to the linear motion. So in linear motion we have displacement, in circular motion you have angular displacement. In linear motion you have velocity, in circular motion we have angular velocity, and similarly we have angular acceleration. So generally angular displacement is denoted by theta, angular velocity by omega, and angular acceleration by alpha. So omega is d theta by dt, alpha is d omega by dt. If it is a tangential velocity, then it is given by omega into r, and its magnitude is that is a vector multiplication, omega and r, and its magnitude is omega r. The direction of the angular velocity is always along the axis of rotation, and that direction is given by the thumb rule, right hand thumb rule. So these terms you must be very clear of circular motion. What differentiates the regular circular motion and uniform circular motion is, in the uniform circular motion the speed also remains constant, and what changes is only the direction. So the velocity changes, but the change in velocity is because of the direction and not because of the speed. Speed remains constant, that is uniform circular motion. The acceleration responsible is basically because of the change in direction, and it is the centripetal acceleration. Centripetal acceleration means the acceleration is always directed towards the center, and its formula is a is equal to v square by r, where v is the velocity, or it is omega square r, where omega is the angular velocity. For uniform circular motion, if t is the period and n is the frequency, then omega is 2 pi n is equal to 2 pi by t. This relation you must understand, where omega is the angular velocity and n is the frequency of motion and t is the time period. So this relationship is important. In non-uniform circular motion, like when you are switching on the fan or switching off the fan, there the speed also changes along with the direction, and hence it is a non-uniform motion. This involves two types of acceleration. If the uniform circular motion is non-uniform, you will have radial acceleration as well as you will have tangential acceleration. So centripetal acceleration changes the direction of velocity, and tangential acceleration changes the magnitude of velocity, that is, it changes the speed. So both the accelerations are the tangential as well as radial in case of non-uniform circular motion. That you have to understand as compared to, and compare it with the circular motion which has only the centripetal acceleration. Then we also understand that there are two forces, one is real and other is pseudo. Whereas real forces are centripetal forces. It is basically a resultant of all the real forces acting towards the center, right? So it is mv square by r, and it is centrifugal force, which is a pseudo force, and it is a non-real force experienced in a rotating framework, a non-inertial framework, and it is again given by plus mv square by r. Centripetal is minus mv square by r, and this is plus mv square by r. So it balances the centripetal force in a non-inertial frame. So centrifugal force is not imaginary, it is a real experience in rotating frames, and it can be measured by instruments. So though it is called as pseudo, it is to be understood that it is a real experience but in the rotating frame, reference frame, and hence we can also measure it. So it is not unreal. An important application of motion, circular motion, is the vehicle on horizontal circular track. Okay. So when a vehicle turns on a horizontal road, there is a turn, let us say. So the static friction would provide the centripetal force, and there are three forces acting on the vehicle. One is the weight of the vehicle acting downwards vertically, and there is a normal reaction acting vertically upwards. The normal reaction would balance the weight. But then there is a third force which is acted towards the center, and that provides the necessary centripetal force for turning. That is a static friction. So the static friction is mv square by r, and it must not exceed mu s into n. And the same speed formula is under square root of mu s r g, where mu s is the coefficient of friction. So mu s r g square root is the maximum safe speed on an unbanked road or on a horizontal circular track. We have seen in physics what is known as the well of death or mouth ka kua, where there is a cylindrical wall and where the vehicle perform horizontal circles, right? So in such a case where the rider is riding in a mouth ka kua, the normal reaction provides the centripetal force, because now he is riding on the cylindrical wall. So the normal reaction will provide the centripetal force, whereas the static friction prevents the downward slipping of the vehicle. So in that case, the normal force is mv square by r, and the static friction is mg. So the minimum speed with which he has to move without falling down into the well is given by under root of rg upon mu s. Rg upon mu s. Below this speed, if he is slow, then the vehicle will slide down, as the friction cannot then support the weight of the vehicle. Okay. The third important case of this circular motion is the banked road. So the banked road means you know that the roads are not flat at the turning. It is slightly tilted at some angle theta, and that is to reduce the dependence of the friction, because you know now that we had seen that on an unbanked road or on the horizontal road, it is a friction which is providing the centripetal force, right? So the roads are tilted in order to have a safe turning, and that tilt is called as the banking of the roads. So the normal reaction then has a components that balances both the weight, and it also provides the required centripetal force for safe turning. So the most safe speed for a given radius r, and if the banking angle is theta, that formula now is under root of rg tan theta. The banked road, the maximum safe speed formula is under root of rg tan theta, where theta is the tilt or banking angle, and it is given by tan inverse of v square by rg, right? So the speed limits with friction coefficient formulas are given, right? Speed limits means the lower range and the higher range, and these formulas you need to remember for banked roads. The other important application of circular motion is conical pendulum, which we'll take up in the next class.